Hello everyone, welcome back to my channel, the Python Gurukul. Today we'll be talking about Python exception handling. We'll be going through syntax error or exception, try, except, else, finally, and range statements. We got a lot to talk, so let's keep moving. We'll start with errors, and many times while writing the program, we'll end up with the errors. And then we try to figure it out that is it syntax error or exception. So let's put it straight. Whenever we are writing a program and we missed spaces, colon, or operators, it will end up syntax error. And whenever we hit the syntax error, our program execution will end and will throw the error, and we have to fix the error to continue further. But but whenever program is running and we encounter unexpected situation, then the program flow will be changed. But if we don't have handled them, then yes, our program will end over there too. So let's see one quick example of the syntax error. So in this diagram, we have simple if condition where we are trying to compare 7 with 5. But what we did, we missed to add colon and we'll end up with a syntax error. Let's do the deep dive into the exception. As we discussed, exception is something which occurs at the runtime. Whenever it occurs, it gives us the control. By using those control, if you provide the mechanism, we'll be able to handle them. If don't, then our program will end. And if the program ends, we don't want to be in that situation. So a couple of the things we need to note here. One is where the exception could occur. Second thing, what kind of exception it could be. And third thing, what we want to do. So let's do these things one by one. Let's start with this image where we are showcasing that we have one message, it is just a string, and we are trying to read that string message of 100. Of course, this is not too long, and we'll end up with the error. But this error is exception, and if you know, we can handle. See the another situation. Our program is well and good, but we are expecting input from the user, and user is free to enter any number. User can enter 0. In that situation, we are dividing 100 by 0. What will happen over there? 0 division error. So what we could do about it? So then we have a try and except statement. Any error which could be prone to throw the exception, we can keep them inside the try block. And just following the try block, we can have the except block where we can accept the exception and handle them. So if something went wrong here while executing the print command or print message, and we have placed in mechanism to handle that, our program will not fail here. Our program flow will change. We hit the exception, we'll go to the except block, and we'll be doing whatever instructed to do. In this case, in this example, we are just saying, okay, print this message, and we are good to go. Another very beautiful example, what we are doing, we are looking into a previous example where we provided input as a 0, and then we'll end up with a 0 division. But what we did now, we know that it could be the error prone. We have put the error prone thing inside the try, and following the try, we are trying to handle this exception. So this is really good example. We should quickly take a look at this example and try to play with it. So what we are going to do, a couple of the things. First, change the program, go to the command prompt, and from the command prompt, we will try to run this program. So I'm just calling Python and except 1. And what just happened here? So we got the index error occurred, and then we are saying end of try except block. So two things I want to showcase through this example. One is, okay, we got the exception, but what we did, we have placed the mechanism to handle that. That's where we are saying that, oh, something has happened. Now we know about it. We can do whatever we want to do. And then I'm showcasing that our program is not ending. After that, we are continuing with the last print statement. So we were able to identify the exception, we printed the message, and then we are continuing the flow. Let's do something different this time. So what I did, I'm just making sure that this time we'll not hit the index error exception, but we'll come up with something else. So let's see what has happened here. Again, we are running the same program. What just happened? We got the A. So this is the print message of 10, maybe this particular E, we got printed. But after that, it is asking a number to divide 100. Okay, let's give some number, maybe 10. What has happened just now? So as soon as we gave the 10, we were able to continue here and no exception occurred. So these blocks are untouched. We have not printed a zero division error. We have not printed index error. What we are just saying, end of try. Okay, we said division result is 10, and then we are printing the end message. But nothing has happened inside the except block. Let me change the program. Let me rerun the program with different input and then see what's going to happen. Now I'm going to input 0. And we are expecting exception 0 division error. Let's see what it does. Okay. So this time, it is able to catch that exception and destroying the appropriate message, and then we are going to our existing flow. So that's all with the multiple except. Let's go back to our slide and take a look at the else statement. So else is very useful to handle situation where we were expecting the exception and we did not got the exception. So in those situations, if you want some code to be executed, we can put inside the else. So let's see what we are doing here. So this fancy program, we are just saying that from the argument, from the command line, we'll pass one file name. Whatever we pass, we are just capturing that, and for loop is going to go through all those input whatever we provide, but our interest is inside the try block. So we got one file. If something wrong with the file, we'll come up with the except OS error. But if nothing is wrong with the file, then the else block will be executed. So let's go back to the program and run the program 2 times. One to make sure that something went wrong, and another time when we make sure that nothing went wrong. So to run this program, we'll go to the command prompt and we'll say Python except and call the else. Okay, and give some name which does not exist, like does not exist .py. What will happen? We'll get that argument, we'll try to open, but it does not exist. We'll hit the OS error and we'll print cannot open the particular file. So this time, whenever exception occurs, we are not going inside the else blocks. That is the thing we want to showcase here. So what happened? We went to this file does not exist in this location, and we got the exception, we handled, and we just said, okay, we know what's went wrong. We'll be not able to open the file. Now I'm going to run the program, same program once again, but this time I'm going to just pass our previous program, except one.py, any file which exists, so that the exception will not occur. At this time, Oh, maybe spelling mistake. Let me check one. So, okay, and run the program. So what it says has 11 lines. It just went through the program, counted the lines, and that's what it is printing. So with this, we are just showcasing that when exception occurred, we are going to the except block. If it does not, it will be going to the else block. Okay. Let's move on to finally. This is one of the very important. It is very useful whenever we want to make sure that we want to do the cleanup before program ends. So one example I have taken that let's we are doing something with the file. We opened the file, we did something, and then exception occurred, and we are not able to close the file. So in those situations, we can have the finally block and make sure that any open connection, any uh, open or not handled objects are there, we can close them and we can do the cleanup. So our try block start here. It's the same program. It got the except error. But what we are making sure that doesn't matter this exception occurred or not. In all the situation, we want to make sure that finally gets the file gets closed. So the straight way we can say that no matter what happened, we want this particular block of code to be executed. In those situations, we'll put this block of code inside the finally. So let's go back to the example. And this time we'll go to the except finally, and we are going to the command line. And from the command line, we will call the Python and then except finally. And this time we are going to pass, uh, let me change this program. So maybe 100 so that we get the exception and we are making sure that we are closing the file. So okay, so we are opening the file into the right mode, so no matter, we can give any file. So I'm just saying new file.py. Okay. Index error occurred because it was trying to read argument of 100. This particular block of code got executed, but we are also going to file object and we are closing that. Let me run this program one more time, and this time make sure that we do not hit the exception at this point, and then also we are closing the file. So again, we are calling the same program. We printed something in, and now we are calling file object that just closing. So in both situations, when we got the exception, when we did not got the exception, the finally blocks are getting executed. So let's move to our final slide. And here we are talking about the raise. So it is very helpful tool for the Python developer. We can choose to throw an exception if condition occurs. And in this example, we are just showing the same thing. At this particular condition, we want to alert our end user or whoever using our code that, okay, whatever we got, we were not expecting, and it is type error. So this way we'll be able to control our program and pass on our function, whoever is going to use, they can throw the right exception. So that's all I had for today. Thank you all for watching. If you like, please share and subscribe. Thanks for your time.